So the new topic is geometric relationship, and in this geometric relationship we are going to see the length of a chain, because in the bell drive we have seen chain. So length of chain can be derived with this help. Sprocket is the main part which help us to find out the chain length. Here d is the pitch circle diameter of that sprocket, alpha is the angle, it is the pitch angle. So this is the sprocket here, this is how it done. So alpha is this angle and this is the pitch, that is the distance between these two links. Okay, we knew that. Now the alpha is equal to what? 360 divided by z. Definitely based on that you will get alpha. So z is nothing but the number of teeth on the sprocket. So sine of alpha is equal to sine of alpha by 2 is equal to what? P by 2, that is pitch by 2, divided by capital D by 2. Or you can say capital D is equal to P upon sine of alpha by 2. With the help of this we can find out the diameter of sprocket. So capital D is equal to this, so 180 by z, that is the number of teeth. We can say this thing. So the velocity ratio can be given as I is equal to n1 by n2 is equal to z2 by z1, where n1 n2 are the speed, z1 z2 are the number of teeth. V is the pi dn by 16 10 to the power 3. So velocity will be changed here as v is equal to zpn by 16 10 to the power 3, because number of teeth is added here. Capital D is equal to what? Z into P. So the length of chain is what? It is expressed in this term, that is L is equal to ln into P, that is the pitch. Length of the chain, ln is the number of links. Now number of links can be found out with the help of these terms. This is the final relationship for the number of links. Ln is equal to a by p plus z1 plus z2, z2 minus z1 by 2 pi square into p by a. Now here a is the center distance, z1 is the number of teeth on smaller sprocket, z2 number of teeth on larger sprocket. So the belt length we find out with the help of some formulas, but here number of links are there, so it is somewhat different. Here the first two terms, these two terms explain what? When z1 is equal to z2, and the third term takes into consideration the inclination of the side. Okay, the inclination of the side. Based on this it has been derived. So the number of link is adjusted to the previous or next digit, and we know that it should be the whole number. We can't say it can be the rational number or somewhat in a point value we can give. So when the chain has an odd number of link, an additional link is added, because it should have a even value, and that link is known as the offset link. Now however, the weaker than the main links, it should be weaker. So exact number of link, the center of center distance can be changes. So this is the formula for find out the center of distance for the chain link. With the above formula you can find out the number of links, and with the help of this you can find out the center distance. Now the center distance is calculated without giving any sag, because chain doesn't have any sag, but in a practical way it is should be there. So this is the value, that is a should be 0.002 times a to 0.004 times a. This much sag we have to add it here. So this is how the geometric relation explained, that how we can find out the center distance and the number of links on the chain. Okay, thank you.